everyone. The question is the a current of 10 ampere flow around a closed path in a circuit. This is the closed path. Current I equals to just 10 ampere. The I equal to 10 ampere flows around a closed path in a circuit which is in the horizontal plane. This circuit is placed in a horizontal plane. Okay, this is placed in a horizontal plane shown in the figure. The current consists of 8 alternating radii, which is R1 equals to 0.08 meter and R2 equals to 0.12 meter. This R1 equals to 0.08 meter and R2 equal to 0.12 meter. R2, this is the R1, this is the R2. And current I equal to 10 ampere is flowing, let us suppose, in anti-cloud direction as shown in figure. Each subtend same angle at center. Each segment subtend same angle at the center. Then find the magnetic field produced by this circuit at the center. Find the magnetic field produced by this circuit at the center. Find the magnetic field produced by this circuit at the center. Okay. As shown in figure, the current I is flowing for this circuit. There are the two type of arc. First one is the radius R1 equals to something and R2 is just something, and this one is the straight current carrying wire. Okay, we have to need a magnetic field at the center. First question is saying that, in that we can say we have to need the magnetic field, means R1 equals to we are right here, R1 equals to the value of R1 equals to 0.08 meter and R2 equals to 0.12 meter. Each angle at origin, each segment same angle at the origin. First, we have to find the magnetic field at the center O. Also, current is the given. I equals to the 10 ampere. Okay. This question is I.I.T 2001. This question is the I.I.T 2001. Imply that we can say we have to need a magnetic field. Okay. Firstly, we are trying to find out the magnetic field at the center. For each circular segment, the same angle we subtend at the center. Let us suppose for this segment at same angle alpha, for this segment same angle alpha, for this segment circular same angle alpha, for this segment at center angle alpha, for this segment alpha, for this segment alpha. Okay, there are the 8 segment. 1 2 3 1 2 3 4 5 6 7 8. Okay, so total at center total angle equal to 360. Imply that there is the 8 part will be given. Okay, so we are trying to find out the angle alpha, or we can say beta. Total angle for the circular path 360 divided by 8. 360 divided by 8. Okay, so we are dividing the number 4. Okay, 4 2 ja 8. So 4 9 ja 36 0. So 90 divided by 2 equal to 45. 45 means that is the angle pi by 4. Pi by 4 is the radian. Okay. So angle for each part, the angle beta equals to the pi by 4 radian. Beta equals to the pi by 4 radian. Okay. We know that for a circular path, for these situations, angle, this is the O center. So this is the circular path. Current I is flowing. This angle beta equals to, this angle beta is the given. So magnetic field due to circular path, magnetic field due to circular path equals to mu naught by 4 pi current I angle beta divided by radius r, divided by radius r. Okay, current I angle beta divided by radius r. So this beta angle must be in the radian. Okay, I is given and r is given. R is the radius of the circular r. Okay, magnetic field due to a straight current carrying wire, mu naught by 4 pi I by r into sine of phi 1 plus sine of a phi 2. Okay, if we need a magnetic field due to a current carrying wire, let us suppose this is the current carrying wire. If we need a magnetic field, imply that we can say this is the perpendicular distance from the required point. Let us suppose required point is the O for a straight current carrying wire. We are drawing to perpendicular on this wire which is equals to the R. Okay, or we can say A perpendicular. So mu naught by 4 pi I by A perpendicular into sine of, this is the value phi 1 plus sine of phi 2. This is the phi 1 and phi 2. Okay, phi 1 phi 2 is what? Phi 1 means we are trying to find out the angle. Angle means perpendicular length, it will be angle in opposite sense. This is the phi 1 and this is the phi 2. Phi 1 and phi 2. So this is the phi 1 and this is the phi 2. So perpendicular distance, this is the phi 1, this is the phi 2, that is the in opposite sense. Let us suppose this is the in anti-clockwise and this is the in the clockwise. Okay, sine mu naught by 4 pi I by A perpendicular sine phi 1 plus sine phi 2. So phi 1 phi 2 in the opposite sense. Okay, so but we are trying to, firstly we are trying to find a circular part. Circular part means there is the 8 circular part, but 4 circular part are the different radii. This is the 4 circular part is the radius r2 and first circular part is the radius r1. Okay, so angle beta equal to pi by 4 in the radian. Okay, B net means we have to the magnetic field due to the R1 circular part. Okay, equal to mu naught by 4 pi I. I current is same. I beta. Beta is what? Beta is the pi by 4. I by R. R equals to, let us suppose R1. Let us suppose R1. Okay. R1 is what? After that we can be calculate here, but we have to need a magnetic field at the center. Okay, so due to R1, let us suppose this is the first segment, this is the first segment, second segment, third segment and fourth segment. For this segment, if we need a direction of a magnetic field, then according to the thumb, direction of a current, and this thumb is going to the direction of magnetic field. So this is the current and this is the magnetic field. Current and magnetic field, current and magnetic field, this is the current and magnetic field, current and magnetic field. For 4 cases at radius r equal to r1, there is the 4 cases. So net magnetic field due to r1 equal to 4 times of magnetic field due to a single segment. In that we can say b r1 equals to, we are putting the value mu naught by 4 pi. Mu naught by 4 pi equal to 10 raised to minus 7 into current I. Current I is the 10 ampere divided by r1. R1 is what? R1 equals to the 0.08 meter into pi by 4 into, right here this value equals to the pi by 4. Okay, so direction of magnetic field, if we put this plane in the xy plane, if we put this plane in the xy plane, then direction of magnetic field will be the outward, or we can say according to the z axis. Okay, if direction of magnetic field which will the perpendicular to the plane, perpendicular to the plane which is denoted by the circle and dot. if inside the plane which is denoted by the circle and cross. Okay. And similarly, we can say magnetic field due to the R2 radius equal to mu naught by 4 pi I into I divided by R2 into pi by 4 into pi by 4 equal to 10 raised to minus 7 into current I divided by radius R2. Radius R2 is what? 0.12 meter into, that is the pi by 4. That is the pi by 4. Okay. Magnetic field due to R2, which is the vertically upward, means if this plane is kept in the xy plane, then direction of magnetic field will be the along the plus z axis, implies that this is the just outward direction. Okay, so both direction due to a r1 and direction due to a r2 will be same, but b net due to r1 equals to the 4 times, because there is the fourth segment here. Rather we can say magnetic field due to a r1, which will be equal to 4 times of a mu by 4 pi I by r1 pi by 4. Okay, similarly you can say for r2 4 times of that number, or we can added then multiply the number 7 finally. Okay, so magnetic field due to that number, so B net equal to the 7 times of mu by 4 pi, adding this number. Okay, 10 raised to minus 7 and 10 and pi by 4 will be common. In rather we can say 10 raised 10 common, 10 raised to minus 6. Okay, 10 raised to minus 6 into pi by 4 into what will be the pi by 4. Okay, that value will be 1 upon 0.08, 1 upon 0.12, so that will be added 1 upon 0.08. Okay, plus 1 upon 0.12 added, point will be removed, in parallel we can say this is the 100, point will be removed, this will be the 100 means 10 raised to 2, 10 raised to 2, so 10 raised to 2 will be common here, 10 raised to 2, 10 raised to 2, so 1 upon, so 10 raised to 2, 10 raised to minus 6 into 10 raised to 2, which will be equals to 10 raised to minus 4, 10 raised to 2, this will be equals to the 10 raised to minus 4. Okay, this will be the 8, imply that we can say there is the 4 number can be common here, so 4 number can be common, so you can say this will be the 4, 4 2 ja 8 or 4 3 ja 12, 4 3 ja 12, 4 will be common, so 4 into 4 will be the 16. Okay, this will be the 16, so this number is the 3 plus 2 divided by 6, so B net equal to the pi into, yes 7, this will be 3, this will be 2, so 3 plus 2 equals to 5, imply that 5 into 7, which will be equal to 35, because 7 into 5, which will be equal to the 35. Okay, 35 divided by, this will be the 6 into 16, this is the 6 into 16, 16 into 6. Okay, into pi, so this number into 10 raised to minus 4. So this is the net magnetic field, this will be the just B net, this number will be in the Tesla, because magnetic field will be in the Tesla. Also we can calculate here 35 means 3 plus 2, 5, 5 into 7 equal to the 35, 37, 35, 7 into 5, 35, 2 into 3, 6, so 16 into 6 and into pi into 10 raised to minus 4. This will be in the Tesla. So this number in the Tesla. Okay. So this is the final value. Also you can calculate here, if value of pi will be put 3.14. So this will be your answer. Okay. We are added because direction of magnetic field will be the upward. If 1 due to R1 will be inward, due to R2 will be outward, then that will be created the difference. Okay, if greater value, then that will be effective. If let us suppose 3 minus 1, let us suppose 3 minus 1, So 3 minus 1 according to the just which value effective will be greater, so that will be effective, or upward effective or downward effective. If upward effective, then x, y, z. So according to the plus z effective. If downward effective, then b net will be the vertically downward, yeah, minus z axis. Okay. Also we have to calculate the a different number. Current I is given, which will be equals to the 10 ampere. Current I is given, which will be equals to the 10 ampere, which is going inward. And this wire is the infinite length wire, which current is going the inward. Means I equals to 10 ampere. The current is going through the center, which is going the inward. Force acting on the wire at the center due to the current in the circuit. The force acting means we have to need the force acting on wire at the center due to the current in the circuit, means we have to need a just a force due to a current is going, आपका infinite current is going, infinite length straight current carrying wire which is placed at the center, which direction is the vertically downward. Okay, so we have to need a magnetic force, we have to need a magnetic force, sorry, we have to need a force. Imply that for calculating the value of force, what will be effect? Okay, also that is the important number, the magnetic field due to a straight current carrying wire, because this is the R1, let us suppose this is the R2, and there is the 1, 2, 3, 4, 5, 6, 7, 8. 8 straight current carrying wire. So we know that according to the straight current carrying wire, there is the no any magnetic field will be created at the center. No any magnetic field created to the center. Okay, because we know that the value will be known as that number if always magnetic field due to a straight current carrying wire. Okay, magnetic field due to a straight current carrying wire mu naught by 4 pi, because there are the three types of a segment, two circular, one type of straight current carrying wire. Then two circular means first one is the R1 and second one is the R2, but we have to need a magnetic field at the center O. Also we have to need a magnetic field due to a straight current carrying wire type, means we are trying to find out the magnetic field due to a straight current carrying wire, means we can say magnetic field due to a straight current carrying wire mu naught by 4 pi I by a perpendicular into sine of phi 1 plus sine of phi 2, sine of a phi 1 plus sine of a phi 2. Okay, so this concept will be applied for this type of a, let us suppose this is the current carrying wire at O point. We have to a magnetic field due to this current carrying wire. Okay, so we are trying to the perpendicular distance from the center O to this wire. This is the AB segment. Okay, so this is the perpendicular. Okay, so this length will be the A perpendicular. Okay, so from perpendicular, so this is the segment will be the phi 1 and this segment will be the phi 2. So this angle phi 1 and phi 2 must be from perpendicular distance. This is the phi 1 and this is the phi 2. And that will be the three numbers will be important. A perpendicular. If we have to need a magnetic field at that point, so A perpendicular will be needed and phi 1 and phi 2. Phi 1 and phi 2 will be in opposite sense and that will be measured from the just A perpendicular. This is the, let us suppose phi 1 is given as shown in figure clockwise and phi 2 must be a anti-clockwise. Okay, so this formula will be valid for this type of. So for these situations, if we treat it as this number, we have to need magnetic field at O point. Okay, phi 1 is this and phi 2 is this. Okay, phi 1 is this and phi 2 is this. Imply that we can say phi 1 is 0 and phi 2 is the 0. Phi 1 and phi 2 both will be 0. or we can say phi 1 0 and phi 2 90. In fact we can say, sorry, phi 2 180. In fact we can say phi 1 0 or phi 2 0. So 0 plus 0 equal to 0. So net magnetic field due to one segment 0, due to next segment. Similarly we can say same logic will be applied. So this will be the due to state current carrying wire, all type of state current wire magnetic field will be equal to 0. So there is the no effect of magnetic field due to a state current wire, only two type of wire. This is the R1, this is the R2. So net magnetic field which will be due to R1 and due to R2, not effective due to a state current wire. So this is the three type of magnetic field. One type of magnetic field due to state current wire equal to 0, another two type of equal to non-zero, which is given. But we have to need a magnetic force on the wires. Okay, we have to need a magnetic force on the wire. We have to need a magnetic force on the wire. Okay, due to this segment, due to wire on the these two segment, this and segment. Okay, need a magnetic force on wire. Need a magnetic force on wire. Okay. Firstly, we are trying to find out the magnetic force due to AC and CD. Okay. Magnetic field due to AC and CD. The current is going the inward. So direction of the direction of magnetic field will be what? The current is going the inward. Okay. If current wire is going the inward, so direction of magnetic field will be in these directions. Okay. Let us suppose the wire is this situations. This is the cross, means current is going the vertically downward. Okay. So magnetic field will be the at this point will be the tangent. Magnetic field will be the in this point will be the tangent. So circular magnetic field will be created. Circular magnetic field will be created. That is the circular magnetic field. Also this is the circular magnetic field. Okay. So this is the circular magnetic field will be the created. This is the circular magnetic field. Okay. At that point, if we need the magnetic field, then that value will be the circular magnetic field, because current is going the inward. At this situation, if we need a magnetic field, then perpendicular at that point. In further we can say, if is this point we have to need a magnetic field, then that value joining at that point, and that is the perpendicular. So you can say at any location, if we have to record the direction of magnetic field and value is this situation, then that value will be the direction of magnetic field. Okay, we are trying to find out the magnetic field in this situation. Let us suppose AC. Okay, current and current due to the AC. Due to the AC is what? We know that is the AC. We are constructing the figure AC. This is the A point and C point. This is the A point and C point. This is the current is going, which is the vertically downward. Okay. AC is what? This is the AC. Current I equals to the 10 ampere. Current I equals to the 10 ampere. Okay. Current I is going, is this situation due to current I. In these questions, we have to need a magnetic force due to current I, which is going the inside and infinite length. So due to this wire, the magnetic field will be the tangentially, means direction of magnetic field at any locations, which will be the in this side. This is the direction of magnetic field. Okay. So this is the direction of magnetic field, perpendicular. Perpendicular, the direction of will be the magnetic field. Perpendicular, the direction of magnetic field. Perpendicular to the direction of magnetic field. Okay. But we know that the magnetic force which will be equals to the Fm equals to I L vector cross B vector. I L vector cross B vector. Okay. L length vector and B length vector. L length vector along to the tangent. Okay, sorry, along to the current. And B is the direction of magnetic field. If we treated A to B, A to C situations, in further we can say this is the L effective and B effective. This is the L effective and B effective. L effective, let us suppose a small part. Let us suppose is this part. P and Q. If we are treating the P and Q, then L vector is what? L vector will be the along the current. So this is the L vector. In that we can say this is the, let us suppose a small L vector, dl vector. So dl vector direction of a length vector which will be along the current. We are treating along the current, elementary length. We are treating the along the current. This is the dl. So L length vector. If we treated the dl, so a small distance dl, we are treating the magnetic field will be in this situation. So this is the dl vector, this is the b vector. Angle which will be equals to the 180. So you can say dl vector cross b vector, a cross b, mod a mod b sine of a theta, theta equal to 180, sine 180 equal to 0. So magnetic field due to a circular wire which will be equals to 0. So magnetic field due to a circular wire which will be equals to the 0. Imply that we can say this is the circular wire, this is the circular wire, this is the circular wire, also for all type of circular wire, because current anti-clockwise, and all type of circular wire the dl vector and magnetic field vector is always 180. Imply that we can say magnetic field, magnetic force on the circular wire due to a current infinite length straight current which is up to the center is inward directions. So you can say on the circular wire the magnetic force will be equal to the 0. Okay. Now we are finding out the magnetic force due to a straight current carrying wire. Okay. We are finding out the magnetic force due to the straight current carrying wire. So magnetic force due to a straight current carrying wire is what? This is the straight current carrying wire. Okay. We have to need a magnetic force due to a straight current wire. Okay. For these situations, the magnetic field is this. Let us suppose this is the center, current I is going, and this is the distance. Distance is equals to the CD. Distance is equals to the CD. And current I equals to the 10 ampere. Current I equals to the 10 ampere. Okay. So this is the center. Center is what? This is the just after current I equals to the 10 ampere. This is the CD length. This is the CD length. Okay. So direction of magnetic field. Direction of magnetic field for these situations will be the downward directions. This is the direction of magnetic field. Okay. Direction of magnetic field. But direction of magnetic field will be variable. After some time, we have to calculate the direction of magnetic field on CD due to a straight current carrying wire. But we are finding out the method what will be happened. The direction of magnetic field will be on the CD will be what? We are trying to the direction of magnetic force. This is the direction of a magnetic field. This is the direction of a positive charge or direction of a current, or opposite to the direction of a negative charge. This is the magnetic force. In parallel, we can say this is the direction of a magnetic field. Direction of magnetic field will be inward. Okay. Direction of magnetic field will be the downward, and this will be the direction of a current. Direction of a current is this direction of a magnetic field in these situations, and this is the direction of a magnetic force. Okay. So direction of magnetic force will be the downward. If this is on the plane, this is downward, so direction of magnetic force will be the downward. This is the direction of magnetic force on the CD. Okay, direction of magnetic force on the CD. Okay. Now you can say direction of a magnetic force. Direction of magnetic force on the these situations. Okay. If direction of magnetic force on these situations, let us suppose this is the C1 and D1. C1 and D1, so direction of a current is the downward. Direction of a current is the downward. So imply that we can say the direction of a magnetic just force. What will be direction of magnetic force? This is the direction of a magnetic field. So direction of magnetic field is always the perpendicular in these situations. Okay. So this is the direction of a magnetic field and this is the current. So direction of a magnetic force will be the outward. Okay, this is the current, this is the magnetic field, and this is the just current, and this is the magnetic force. So direction of magnetic force will be the outward. So direction of magnetic force which will be equals to the outward. So direction of magnetic force which will be equals to the outward. Okay. Also, we are trying to find out the direction of a, this will be the just a CD, and this is the C1 D1, another this is the C2 D2. This will be the C2 and D2. C2 and D2. This is the C2 and D2. Okay. Current I is flowing. Current I is flowing in these situations. Okay. So because direction of a current will be changed. So for this situation, direction of a just a magnetic field. Direction of magnetic field will be circular. Direction of magnetic field will be the circular. For these situations, let us suppose for these situations, so this is the C1 C2 D2. So direction of a current will be in these situations. So direction of magnetic field in this perpendicular. This is the B vector. This is the B vector. Okay. So for this situation, direction of a magnetic field in this and direction of a current in this. This is the inward. Okay. So this will be the inward direction of a magnetic force, outward, inward, outward, out, inward. So there is the four cases will be inward and four cases will be outward. Okay. That the magnitude of a force will be same for each segment. For each current carrying state current carrying wire, magnetic force will be must be same. Magnetic force must be same for each current carrying wire. After some time, we are finding the direction of the magnitude of a magnetic force due to a one state current carrying wire. So for fourth situation, direction of magnetic force will be outward, and for fourth situation, direction of magnetic force will be the inward. Magnitude must be same for each current carrying wire. So there is the 4 vector outward, magnitude same, 4 vector inward, magnitude same. So net magnetic force will be equal to 0 due to a state current carrying wire. Net magnetic force will be equal to 0. Not a for a particular wire, net magnetic force equals to 0. For two wires, one आपका करंट इनवर्ड और अनदर आउटवर्ड, नेट आपका मैग्नेटिक फोर्स विच विल बी इक्वल टू 0. ओके, सो डायरेक्शन ऑफ अ मैग्नेटिक फोर्स, one outward, one inward, this pattern. Now we are finding out the value of a magnetic force due to the AC. Magnetic force due to AC which will be equal to 0. After some time we are discussing here direction magnitude of a magnetic force due to the AC which will be equal to 0, because this is the length vector, this is the magnetic field vector, this is the opposite. Imply that we can say mod A mod B sin of a theta equal to 180. So magnetic force due to one circular wire, yeah, due to any circular wire particular, that must be 0. For each circular wire the magnetic force equal to 0, but for one state current wire the magnitude of a magnetic force cannot be equal to 0. Okay, so for each circular wire, but we are in the question is given, we have to find out the value of magnetic force due to AC which will be equal to the 0. Now we are finding out the value of magnetic force. Value of magnetic force due to the CD branch. Let us suppose this is the current I. Current I equals to the 10 ampere, and this is the CD. This is the, let us suppose this is the CD branch. So this is the C and D, CD branch. Current I equals to the 10 ampere. This is the I equals to the 10 ampere. Okay. This is the current. This is the current which will be downward, and this is the CD, and this is the current I equals to the 10 ampere. Okay. So that distance is what? So that distance is the R1, and that distance which will be equals to the R2. Okay. This is the R1 situation, this is the R2 situation. This is the magnetic field which will be the vertically downward. This is the CD, this is the CD. Current I equals to the 10 ampere. Current I equals to the 10 ampere. Okay. So due to this infinite current carrying wire, the direction of magnetic field will be the downward. Okay, direction of magnetic field will be the downward. So this will be the direction of a magnetic field, which will be the vertically downward. Okay. Here you can say the value of magnetic आपका force. The value of magnetic force. Okay. The value of magnetic force equals to the I L vector cross B vector. I L vector cross B vector. Okay. Due to this current carrying wire, we have to need a value of magnetic force on only on the CD branch. Okay. So for this situation, we are calculating here. But we can say for these situations on CD branch, the value of magnetic field will be changes continuously. Value of magnetic field will be changes because if we moving C to D, then R will be changed, so magnetic field will be changed. Okay. This will be the straight current carrying wire, which is directly will be the vertically downward. Straight infinite current carrying wire. So at a fixed distance, the magnetic field will be constant, but at a variable distance, the magnetic field will be the variable. Okay. So for this situation, the magnetic field will be the variable magnetic field. Okay. So for this type of problem, we have to solve at this method. Let us suppose that at distance, this is the dx length. This is the dx length. At x distance, so this is the dx length. Okay. For dx length in these situations, this is the dx. Okay. For this is the small part, or we can say add r to dr. This is the r, and also we can say this is the dr. Okay. So we are concentrating on the dr. For a dr is the small length. So for small length, magnetic field will be constant. Magnetic field will be constant. For this will be the small length, magnetic field will be constant. Magnetic field will be the just downward. Let us suppose this is the magnetic field due to R. Okay. This is the small part. This is the dr length. A magnetic field will be this situation. Okay. Magnetic field downward and dr length will be the rightward. Dr length will be the along the current. So current is going C to D. So dr is going in these situations. So we can say dl vector, yeah, d of m, yeah, magnetic force, yeah, d of m. df equals to current I into, this is the dr vector cross, this is the magnetic field at r equals to r. Okay. dr vector cross br vector. So you can say dr vector cross br vector. Okay. dr vector is what? dr vector is the right hand side, and magnetic field due to r, which will be downward. So angle must be a 90 degree. So angle must be a 90 degree. So mod A, mod B sin theta. Implies that we can say I into dr into magnetic field due to r equals to the r. Okay. So this is the magnetic force on the dr length. This is the small length. So I dr into magnetic field at r equals to the r. Magnetic field at r equals to the r. Okay. Magnetic field due to a straight current carrying wire at r equal to r is what? So magnetic field due to a infinite current carrying wire at r equals to the mu naught by 4 pi I by r, current I divided by distance will be, this will be the r distance, this will be the r distance. Okay. R into, this is the infinite current carrying wire. So for infinite current carrying wire, sin phi 1 plus sin phi 2, phi 1 equal to the 0, and phi 1 equal to the 90 minus 90, sorry, phi 1 equals to the 90 and phi 2 equals to the 90, because that is the opposite sense. Let us suppose infinite current carrying wire, this is the infinite, we have to need a magnetic field at this point. So this is the phi 1 and this is the phi 2. So this is the phi 1 and this is the phi 2. Phi 1 equals to the 90 and phi 2 equals to the 90. So sin 90 plus sin 90. This is not a negative sign put. This is the positive. Phi 2 must be plus 90. Phi 1 must be a plus 90. but this will be the in opposite sense. So sin 90 plus sin 90 equals to the 2. 1 plus 1 equals to the 2. So this will be the 2I by R, because sin 90 plus sin 90, 1 plus 1 equal to 2. So magnetic field due to a state current carrying wire which is put at the origin, which will be equal to that point. Okay. So put here current I into magnetic field at R equal to R mu naught by 4 pi I by R, or we can say 2I by R into, this will be the dr, this will be dr length, this will be the df. Okay, this will be the df. R is variable and dr is the differential element, integral, or we can say integral element. Okay, so this will be equal to the mu naught by 4 pi I 2I into just dr divided by r. Okay, so this will be the df, this will be df. Now we integrate here, just integration df equals to the f mu naught by 4 pi 2I into dr divided by r. Okay, dr divided by r means this is the dr length which is going from C to D. Dr length initial will be C and final will be D. So this is the length will be the just R2 minus R1. But we are starting here from these situations at center O. So R equals to the R1. This will be from C positions. R equals to the R2. So this will be the D positions. So this is the R equals to the R1 lower limit. R equals to R2 will be the upper limit. Imply that R1 to R2, okay, equal to the mu naught by 4 pi 2I integration dr by r dx by x equals to the ln r, or we can say log r, we can say log of r. Okay, lower limit is the R2 and R1, upper limit is the R2, so we can say log R2 at base e, log R2 minus log of R1, log m minus log n equal to log m upon n. In that we can say log of R2 upon R1, sorry, R2 upon R1. ठीक है, just R2 in place of R2 put the value of a 0.12 in place of a R1, which will be equals to the just 0.08. Point will be removed, so this will the cancel the value of 4, 4 2 ja 8, 4 3 ja 12. So log of 3 by 2 at base e. So mu naught by 4 pi 2I into log of 3 by 2, log 3 minus log 2. This will be given value. So putting the value of log 3 minus log of a 2. So this finally you can say this. But some correction will be here. Just I into I. I into I is what? I square. Okay. I into I is the I square. Okay. If current will be same, this is the I current, and in fender state current where is also I current. Let us suppose this is the 10, this is the 10. So also value is the put 2I square into log of 3 by 2, not by 4 pi. Okay.